Hello, welcome to our live webinar. We are Control Byte. I'm Jacob. With me is Matthew. Hello, Matthew. Welcome
Hi.
to all the viewers and our students. Nice to see you. This is live session, so you can write on the chat. We will highlight your comments and we'll be able to answer all your questions. Today's topic, PLC wiring tutorial. So let's start. The first step, let's answer the question, what is actually a PLC? Hello, EMTech. PLC, Programmable Logic Controller. This is the brain of every industrial machine and automation system. This device is responsible for reading input signals, setting output states, processing the user's program, diagnostics, and data logging. On the right, you can see Siemens S7-1200 PLC series with some output modules, and this is temperature reading module. Hello, nice to see you. Okay, this is we are at the start of this meeting, so remember to hit the like button under this video. It will help us a lot with our channel. Okay, why PLCs are used in industrial automation? I have a question for you. You can write the answer on a chat. So why don't we use, for example, Raspberry Pis for industrial systems? Why we use Siemens PLCs, which are extremely expensive when you compare it to Raspberry Pi or Arduino, for example? So the answer is compliance with directives and standards in industrial applications. Tanmay says output load capacity. Yes, that's true. PLC's outputs are suitable for switching high loads. Raspberry Pi is not equipped with transistor outputs. It is equipped only with GPIOs, which are connected directly to the processor. Okay. Nowadays, we are facing fourth industrial revolution, and there are applications where Raspberry Pi boards are introduced into industrial systems. For example, you can find a device, a controller called Revolution Pi. This is from Kunbus. It can be equipped with CodeSys runtime, and you can use it as a normal PLC controller with all the compliance to the proper standards. As you can see, this is operating temperature from minus 40 degrees to 55. ESD protection, 4 kilovolts, and many other tests that this device complies are listed here. And of course, a single Raspberry Pi board is not suitable for industrial environment, and it can just reset with no with you don't know when. Okay, so today's topic is PLC wiring. So let's start with different types of power supply systems in control systems. So there are three different types of power supply in control systems according to standard IEC 60204. Part 1, safety of machinery, electrical equipment of machinery. So you can power your control circuits from the main circuit directly without galvanic isolation. You can power the control system from the main circuit indirectly, where there is galvanic isolation from the power supply, and you can use other source of power, from example batteries, where you do not connect your control system directly to the power supply's power source. Okay, on the right you can see a diagram for connecting power supply in control systems from the main circuit directly without galvanic isolation. And this type of circuits is used in simple machines where there are one or two drives. And here on the left you can see a simple control panel with start, stop button and the main switch. Dedicated control system, power supply for control system is right here on the right. You can see the diagram. What is the difference? From the mains, you power a transformer which isolates your control circuit from the mains, okay? Okay, I see that there are a lot of viewers right now, so hello everyone. Today we have live sessions, so you can write on the chat, you can ask questions, and we can show your comments like right now. Okay, EMTech PLC helps the efficiency of production like manual operation of any machine. Of course, that's true. Okay, and remember to hit the like button under this video to help us develop our channel. Today's topic is PLC wiring, and we start with PLC power supply. We are discussing right now power supply in control systems. So this is the most common, the most standard control system, a power supply for control system, where we use a control transformer. This allows us to divide the power line section and control section. Another type of power supply in control system using galvanic isolation is the use of switch mode power supply. On the right, you can see 24 volts switch mode power supply. This is the standard device in almost every automation system. This is 5 ampere power supply from Phoenix Contact. And those devices are used where you need DC current, DC voltage on the control circuits. A standard transformer can generate galvanic isolation, but you get AC current at the other side of this transformer, okay? And you need switch mode power supply to generate DC current. Switch mode power supply are really sophisticated devices. Here on the left, you can see block diagram of such a power supply. And the best devices on the market are equipped with different types of overcurrent protection systems. So this can provide safe operation of your control circuits. Okay, so I mentioned earlier safety of machinery standard 60204, electrical equipment of machines, general requirements. So let's examine this particular standard. So here on this diagram, you can see the circuit with galvanical isolation from the mains that uses control transformer with DC voltage at the output side. So this is switch mode power supply. And it complies with this standard by fulfilling the rules where ground faults in any control circuit should not cause unintended activation, potentially hazardous movements, or prevent the machine from stopping. So this is the quote from the standard. And this picture, this circuit is also quote from this standard. So this is the way that you should connect your output devices, your output components of your control system, like coils, lamps, and so on, to the power supply in control circuits. Okay, so what is the main rule of this connection? You have to connect the pool of the power supply output to the protective connection of the machine. So this is PE, protection earth connection. Okay, this is the first rule. And the second rule is that you have to connect all contacts and semiconductor elements used to start to release actuating devices. You have to connect them directly to the power supply wire on this side. Okay. So if you want to buy a switch mode power supply for your control system, you have to check if this particular device complies with standard EN 60204 part 1. It means that this particular device, switch mode power supply, is suitable for industrial applications. Okay, so in control circuits, you have to apply protective devices like circuit breakers and fuses. There are different types of protection devices in control circuits. So on the left, you can see miniature circuit breaker. Then A standard fuse with special terminal for this fuse. You can find also modules which are equipped with many fuses. These are fuses blocks. And on the right, you can see electrical protection device from more electronic. Okay, let's check how many likes are there below this video. Okay, there are 17 likes right now. So remember to hit the like button and let's move on with the presentation. Okay, so you know how to create power supply section for your PLC. Now you have to check how the wiring should look like. Okay, we have 2 likes from Jason and from Mahmoud. Thank you. And remember to hit the like button under this video as well. Okay, so now on the slide you can see a piece of Siemens S7-1200 PLC manual. This is the schematics, how the supplier wants you to connect the PLC, okay? So, okay, we have more likes. Beautiful, thank you. So we have a terminal block right here. And from the left, there are L plus and M terminals, which are responsible for supplying DC power to your PLC controller. And you can find here a switch mode power supply, DC plus, DC minus, with ground connection to M terminal, okay? Third like. Yeah, great. Thank you. Okay. So those are helpful tips which can suggest you how to connect your input devices and output devices to your PLC, okay? This is not complete diagram, complete schematics. I will show you in a minute how it looks like in electrical diagram, but it can tell you which potential you should connect to which terminal. And on the right, you can see many important information. The most important is highlighted with number 2. For syncing inputs, connect minus to M. Okay? For sourcing inputs, connect plus to M. So it suggests that you can use input section, input card, as syncing inputs or sourcing inputs, okay? So you can connect either minus to M or plus to M. Every PLC module has such a wiring diagram, so you have to refer to proper document. Okay, we have a question. So AC-DC switching power supply is marked like a battery. This is just a general symbol of DC power supply. It's not a battery, just a general marking, okay? Maybe in electronic schematics, it can be marked as a battery symbol, but in automation systems, I'm sure that every automation technician and engineer will refer this symbol to DC switching power supply. Okay. So in electrical diagram, you can see a PLC on the overall view like this, where you can see how the modules are mounted on the DIN or rack rail. You can also see the diagram where there are all the terminals in the single block. And you can find a method of placing different types of PLC terminals in different blocks. So here you can see input card, output card, analog card, and they are in the different blocks and they refer to the same module. Tanmay asks, is there a specific condition when we have to use and when we have to use sourcing? Yes, I will show it in a minute. I have some schematics for sourcing and syncing configuration. Okay. So you can also find the third method of placing PLC on the schematics. You can divide all the channels on different pages of electrical schematics and then refer to every single channel separately. Okay, so let's move on to check how a standard PLC input should be wired. Here you can see a basic schematic with NO, the green one, and NC, red one, contact. So these are power supply lines with 24 volts. This is the upper line, and 0 volts. This is the lower line. Okay. And here you have 24 volts DC input section. The terminals of this section are marked with 1M and then 0, 1, 2, 3, 4, 5, 6, 7. So we have 8 input channels. So it is 1 byte. And this 1M refers to the potential that the circuit is closed for this section, okay? Hello, Fateh. Nice to see you. Let's go back to wiring by the manual. So you can see that in the manual, the wiring looks like this, where the minus from the power supply is connected to 1M terminal, and plus is connected through the switches to every channel of this input section, okay? So in the schematics like Eplan diagram, AutoCAD electrical, you will find this configuration where you have potential lines at the top. You have the device like a switch represented by the symbol, and you can find PLC diagram like this. We added here a nice image to for you to read this in a clear way. So we have 24 volts here, and the circuit is closed by the switch by this terminal of channel 0, and then it goes to 1M terminal, and the current flows to 0 volt potential. Okay. Now let's see how this input section looks like inside a PLC. Inside PLC input channel, you will find opto isolator. Opto isolator is an electronical device on the PLC board. It looks like this, and it generates galvanical separation between microcontroller, the CPU of the PLC, and the input section, the signals from outside the PLC. Okay, so here you can see a photodiode and phototransistor. If you connect power to, for example, channel 0, the current will flow through the diode, and it will generate the signal, the current flow to the microcontroller. So it generates galvanical isolation between input signals, the noise from outside world, and the CPU of the controller. Okay, and on the slide we have answer for Tanmai's question. When we use sourcing and syncing configuration, so we have to distinguish the name of sourcing and syncing for switches and sensors, and for PLC input sections or cards. The main rule, the main principle is like this. When you have sourcing switch, the PLC input configuration is called sync, okay? And when you have configuration where switch is in sync configuration, the PLC is in source configuration, okay? So if you have switches or sensors in sourcing configuration, it means that your switch connects 24 volts to the input channel of the PLC. And the common terminal 1M is connected to ground, to 0 volts. If your sensor is in sync configuration, it connects the input channel to 0 volts, to ground, and your common terminal is connected to 24 volts. So in Europe, we mostly use a sourcing configuration for sensors, but in Asia, you will find different types of sensors, and they are of type sync. And here on the slide, you can see how to connect standard sensors with 3 wires, brown wire, blue wire, and black wire. Brown and blue are responsible for supplying power to the sensor, and black is the signal cable. So this is the PNP source configuration of such a sensor. When the sensor provides 24 volts on black wire, it is called PNP. And when the sensor provides 0 volts, when detecting the element, it is called NPN. Okay, the cables are of the same color. The connection looks almost the same, but in this configuration, the PLC input card should be in source configuration, source mode, so you have to connect 1M to 24 volts. Okay, we have 29 likes under this video. There are over 30 or 40 viewers, so remember to hit the like button, and we'll continue with the presentation in a minute. Same name like transistors. Yes, this is the same name because those sensors are equipped with transistor outputs. So actually, you can find in these sensors PNP or NPN transistor as the output. Okay, so now let's move on and let's talk about PLC outputs. So here on the right, you can see output section of PLC controller of S7-1200 PLC controller. And this output section is equipped with L plus terminal, M terminal for supplying the output section. And this section consists of 6 output channels, 0, 1, 2, 3, 4, 5. Okay? So those are transistor outputs. And how it is made inside the controller. So it is also galvanically isolated from the microprocessor of your PLC. And at the output, you will find semiconductor driver. And what is the most important for Siemens PLCs, there are only sourcing outputs, okay? So if you program your PLC set output 0.0, here on this terminal, you will detect 24 volts and this LED will be highlighted in green, okay? So those are transistor outputs. And in PLCs, CPUs, and S7-1200 cards, you can also find relay outputs. Relay outputs are a little bit different. Those transistor outputs have semiconductor drivers, And with relay outputs, you will find relays on the electronic board of your PLC. So here on the left, there is a layer of PLC with relays right here next to the terminal. And every relay has one switching contact where you can connect either DC and AC voltage, okay? Transistor outputs are only for DC voltage. And with the relay outputs, you can connect AC or DC voltage. You have to remember about protection of your outputs of the PLC. There are different type of protection devices. You can equip your output with, for example, a diode, a standard diode, a Zener diode, or you can use some more sophisticated solutions, but the diodes are the basic solutions for protecting your output channels of the PLC, okay? Okay, so why you should remember about protection of output channels of your PLC? Here you can see a moment of switching inductive loads of a relay contact. So here is relay with in normal operation, and here is the moment of switching of inductive load. And here you can see an arc generated between the contacts. So if you use a diode here, you will make your contact live longer. So this is the same problem with the relay output of your PLCs. So remember to use protection devices like diodes at the outputs. And for the transistor outputs, the PLC is already equipped with some basic protection devices like diodes on the board of this device. Okay, B says parts damage contact services. Yes, exactly. Okay, so we have over 40 minutes of our meeting, and the theoretical section of our today's meeting is over. So if you have more any questions, write on the chat, and we have some more information for you regarding the next part of the training. Okay, so let's move on to the next part of our meeting. The first part was a little bit theory about PLC wiring. It was just introduction, and we have some information for you about our training. So we are Control Byte, and we provide online training on automation and robotics, on PLC programming and automation systems. So now we have opened registration for automation, industrial automation basics training. This is online course where you can learn how to create an automation system from the scratch. Okay. So I will send you a link on the chat. On this website, you will find all the information about our course. This is the complete course on how to create such a control cabinet with different types of electronic devices used in industrial automation systems. In our courses, we use SolidWorks electrical software to present how those projects are made from the scratch and how you can navigate through the documentation, electrical schematics, and wiring diagrams. Okay? So we are Control Byte, and we deal with automation systems for over 10 years now. For over 4 years, we run automation trainings for PLC programmers and automation technicians and engineers. If you watch this video, I think that you may want to work as automation engineer, automation technician. You want to know how to read electrical diagrams for automation systems. And you may wonder what you should know to start such a job. So we have solution for you. We have prepared a training. So sit back in your chair and see how the automation system works based on a 3D model and simulation, okay? In our training, we provide a wiring diagram for such a pallet wrapper. It consists of almost every automation device that you will find in every control cabinet, like short circuit protection devices, different types of switches, safety relays, contactors, motor circuit breakers, PLCs, VFDs, and many, many more. Okay, so we created such a wiring diagram for you for such a machine, so you can learn how to read those diagrams and how to select equipment for such a project. There are two most important standards for automation systems if you want to service or maintain fixed automation systems, or if you want to design it from the scratch. there is a standard 60204. This is the standard that I mentioned earlier during the first part of our meeting. And the second standard, 61439, is dedicated for particularly for designing control cabinets. Okay, so we based on those standards during our training, and we have case study. We provide you with a 3D model of a control cabinet like this, with all the equipment inside. And here you can see the layout of our pallet wrapper machine with the best machine operator in entire world. And your task will be to design an electrical control panel that include drive control systems, PLC for reading digital and analog signals and setting outputs, HMI panel buttons, and you have to implement basic safety functions for your system, okay? During the training, we use 2D schematics, and step by step, we explain every part of this electrical diagram. We focus on every device in the control cabinet, and what is the best of this training, that you can track the potential. You can track every wire in this control cabinet. So what will you get after signing up for the course? This is the online course where you can get learning materials, over 50 lessons in video format, explaining the basics of automation design. You have lifetime access to the lessons on our e-learning platform. You will have consultations in form of live webinars. We have a Discord channel for our students. So this is our Discord channel. And we have a homework section for automation design course. It looks like this, where you can reach us, you can ask questions, and we answer to your questions and solve your problems, okay? And of course, on Discord, you will have homework assignments to do on your own. So we are running our online trainings for more than 5 years now, and we have proven educational path by hundreds of students. Okay, so in the course you will get more than 50 video lessons. We'll start with introduction to the project. You will see all the assumptions of such a machine, the drive list, the list of signals, and the description of the control cabinet that will base our project on. Then we'll go to module with a selection of electrical protection devices. In this module, you will learn how to connect machine to the power supply at the customer's industrial plant. You will learn how to select power disconnection devices in the control cabinet. You will learn, you will see how to calculate power supply cable, and you will learn about colors of cables used in industrial automation in Europe. So in our course, we step by step describe every device in the control cabinet, like electrical terminals, service sockets, cabinet temperature control devices, fans, heaters, and so on. You will learn how to select overcurrent circuit breakers, fuses, and disconnection devices. We have the whole module on electrical drives. You will learn how induction motors are selected for the project. You will learn about control methods of induction motors, three-phase induction motors. You will learn how to select motor protection circuit breakers and contactors for starting systems. And of course, we have a section with VFDs, variable frequency drives, and servo systems. Today, we talked about wiring a PLC. In the course, you will get a 3D model like this on the right, where you can manipulate with the model. Maybe I will show you. Okay, here you can see the 3D model that we use in the course. And here you can find a PLC controller with all the wiring, where you can see how it is wired physically. And you can compare this 3D model with electrical schematics to know how to refer 2D schematics to real wiring. And today I have made a brief introduction to input-output connection. In the course, it will be covered in wider range. You will learn how to connect input-output devices, how to wire, for example, a control panel like this, how to implement different types of switches, how to select colors for those switches, and many, many more. We have also an entire module over 2 hours or maybe even 3 about introduction to machine safety systems in cooperation with Wieland Electric, a German company that deals with safety systems of industrial machines, and we'll show you how to what are necessary steps to create safe machine and fulfill safety requirements for industrial machines. You need only your computer with internet access to start designing control cabinets. In the course, we use free online tools like Wago Smart Designer to create terminal strips, TIA Portal selection tool to create PLC bill of materials. We use retail configuration for control cabinets. We use Lancet drive selection tool for selecting drive for the conveyors. And you will get electrical schematics in PDF and 3D model of industrial cabinet. Okay, this is Wago Smart Designer, a web tool where you can create a terminal strip from the scratch. This is the terminal block for the motor section. We use TIA Portal selection tool to create a list of CPUs and modules for your project. We use Retail Configurator to configure bill of materials for control cabinet. And many, many more, okay? So you will also get bonuses. The first bonus is access to our Discord channel, where we can talk, we can discuss your problems, and we provide support. The second bonus is electrical schematics guide, where we have gathered all the necessary information to read electrical schematics and create one, okay? And how to sign up for the course. So this is our website. I will send you a link on a chat. This is the website of Industrial Automation Basic course. And here you can find the outline of the course with all the modules enclosed in the course. You will find the list of lessons in the course, the bonuses section, and the price of the course. So now you can see that there is a special offer. We have a huge discount right now. There are only 2 days left, and after Thursday, September 26th, we close the registration, okay? So if you want to join the course, you have to click the big green button. And here you have 2 options. You can sign up for the automation course, Industrial Automation Basics, or you can choose a bundle, Industrial Automation Basics with PLC programming, Siemens S7 1200 and S7 1500 in ladder and FBD language, in really good price. So you will get a huge discount when selecting this bundle right now, and the offer is only until Thursday. Okay, so if you want, for example, this bundle, you have to click on the right column, and we use Stripe for safe, secure payments. Okay, so here you will find different payment methods depending on the country that you are currently in. And you can also add here a basic PLC structure text programming course in CodeSys. Okay, so this is the biggest bundle, the biggest pack that you can enroll in right now. Okay, I have information that something is wrong with my camera. I have to check the settings.
Okay, and I see on chat that you have answered my survey, and I questioned you: is the price 99 euro okay for you? Is it okay for you? And 60% of our viewers just checked the option yes, the price is okay. And remember that right now we have a discount price of our course.
Yeah,
Okay, so this is really good offer, and on this Thursday the price will go higher. So this is a special offer, a discount price. So we have a chance to join our platform in a really good price, 97 euros for industrial automation basic course. And if you want to join with a uh, full pack with programming, student programming, you can do that till this Thursday.
yeah. I suggest you to check our website. We have different courses on PLC programming, on home automation. We have courses on motion control systems in industrial applications like servo drives programming. And now we have special offer for industrial automation basics. So until Thursday, the price is 97 euros. And you can select a bundle with PLC programming course. If you want to job in automation and industry, if you want to be automation technician, automation engineer, so this is must-have bundle industrial automation basics and PLC programming basics in ladder logic and FBD. Okay, so you have time until Thursday. Thank you for today's meeting and thank you for watching. See you in the next live session.
If you have more questions, we have our email address,
Yeah.
contact@contribite.tech, and we have also a hidden WhatsApp group, and you can ask us questions about the course. Here we have the question: is this first module covering all needed knowledge to be able to do automation engineer job? After this module, you will be able to read electrical schematics and choose devices for industrial automation project. Project. So in this course covers essential skills for every automation engineer. And
Yeah.
with that skills, you can just create a CV and send a CV to the future employer.
Yeah, exactly. And if you want to be a PLC programmer for automation systems, this is the second option for you.
Yeah, the full pack covers industrial automation basics, reading electrical schematics, and programming Siemens PLC. Siemens PLC is the most popular model of PLC in Europe. In every factory in Europe, you will find Siemens. That's why it is worth to learn programming in FBD and ladder logic for Siemens. If you want to get a job in Europe, this is the essential skill.
Yeah. Tanmay says, thanks a lot for the live session and course information. Sure, thank you. Sherry says, thank you. Thank you too.
Yeah, and we are waiting for you on our e-learning platform. After purchasing the course, you will get access to our e-learning platform with videos, materials, schematics, 3D model of control cabinet, and you will get access to our hidden group on Discord channel, where our community of industrial automation engineers is constantly growing. We have a lot of people there, and we are working on next courses. So see you in our Industrial Automation Society. See you
Thank
in the
you
next
and bye.
live session. Hi.